Hello, everyone. Today I'm going to be talking to you about modernizing a microservice architecture. Specifically, I want to talk to you about how Constant Contact is leveraging Gloo and Istio as part of our platform transformation. So who am I? My name is Dave Ortiz. I'm a principal software engineer here at Constant Contact. Most of my background comes from the application side. I've been a back-end developer for many years, and a lot of the work I've been doing is on some of the critical core components here at Constant Contact. But these days, I'm spending more of my time with a fantastic group of engineers on our platform team, and we have a very modest goal. And our modest goal is we want to transform the way developers deploy and run and operate their software at Constant Contact. We want to adopt a cloud-native model. So as part of this transformation, there's obviously more here than how we're bringing traffic into our clusters and our gateways and our service mesh. This encompasses everything from our adoption of Kubernetes, from the way we've adopted GitOps. But for the most part, this presentation is going to be how we're using technology like Gloo Edge and Gloo Mesh and Istio as part of this wider transformation. So just as a high-level overview of what I want to do is I want to talk a little bit about Constant Contact's journey with microservices and how we got to where we are today. I want to talk about some of the limitations we've seen and we've run into, and how we're trying to fix them, and how they're causing us to not be able to do what we want to do today. I want to talk about specifically how we're using Gloo Mesh and Gloo Edge and Istio, and how we've solved some problems. And then finally, at the end, I want to let you know where we think we're going in the future. So with that, let's take a quick step back to 2012, before I even was at the company. And at the time, Constant Contact was largely implemented as a monolithic application written in Java. We had a monolithic database. We had a bunch of components. And we were running into the issues that a lot of folks run into when they're running these big monoliths. And it's that, it's operational problems, like you have a big giant database, that's a single point of failure. We were running into performance issues. It was difficult to scale different parts of the product. And on the engineering side, we were running into issues because we weren't deploying the thing fast enough, or often enough, rather. And that was because the deployments were big and complex, and we had a bunch of really smart people who we needed to help us deploy this thing. So when you have big, scary deployments, you don't deploy as frequently. And this monolith was limiting the ability of our teams to choose different kinds of technologies, right? When you have a Java monolith, and the language or the interface between the different components is a Java API, it's really hard to adopt a different language. So we did what a lot of companies were doing at the time, and we started looking at a microservice architecture as a way to kind of solve a lot of the problems we were having at the time. And we did what most folks do. We took all of our components, we built REST APIs for all of them, we pulled them apart, we gave them separate deployment pipelines, and there was a lot of work done. And the idea was that if we had these well-defined REST interfaces between components, we could deploy them independently. Things would move faster, and ultimately that was true. We were able to move faster, and by 2015, we had migrated the vast majority of our system into this microservice architecture. So our major platforms, like our clickstream ingestion, our email platform, our contact management platform, our editors, all of them were rewritten in some cases, or refactored and moved into this architecture. And for the most part, things were really good. We had significantly matured our deployment pipeline. We had initially ran into issues. We had some relatively sophisticated CD pipelines with canaries and rollbacks and all sorts of cool things that we had built on our own. And the reason is that because at the time we had started, we were relatively early to the microservice architecture, and there weren't the wealth of tools and libraries and open source products to help you solve some of the concerns that we ended up having to solve. So being a company that's an engineering company, we came up with our own solutions, right? And we implemented a lot of those solutions as libraries that developers could pull into their microservice. So secret management and authentication between microservices. These are things we had to build, and we did build them, and things were going really well. By 2016, the company was acquired by a larger group, Endurance International Group. And at the time, we were trying to figure out how we could take products and other things that were built around the Endurance, under Endurance, and figure out ways to integrate them into our product. And we had figured out that it wasn't easy, and we had learned a lot. So by 2017, things started to change even more. We had mostly been focused on deploying our microservices in our own private data centers. That was working for us. We felt that it was cost effective. But by 2017, the world shifted a bit because we were trying to run workloads, or we wanted to run workloads that really didn't make a lot of sense to run in a private data center. Specifically, we were looking at these big data, machine learning, and these analytics workloads that may require you to have a lot of capacity for a short amount of time, and we really started to adopt AWS. So the issue we ran into is one, the technologies in AWS were different, and our pipeline didn't support them. So, for example, developers were deploying on-prem with our own automation that would spin up VMs and stick them in a load balancer and do all those things. And in AWS, we were using a different set of technologies. So instead of Jenkins, we were using code build and code pipeline, and things were different, right? We started to notice that there was a bit of fragmentation. The teams were adopting different languages. So at the time, Java was it at Constant Contact, with some of our application written in Ruby. But when we started moving things into the cloud, we started seeing the adoption of things like Python and Go. So things were starting to change. Our existing tooling didn't work well here. Our existing libraries for things like authentication weren't working as well as we wanted to in the cloud. So what happened is what always happens when you're lacking capabilities in your platform, is developers start to fill in the gaps. And they don't always do so in a way that makes sense in the long term. So after a few years of this, we started to take a step back around 2019. We started to see some adoption of Kubernetes, some kind of organic growth, but really hadn't gained wide traction in the company. We had some small products that were deployed on Kubernetes, but by 2020, things were really beginning to change. So we had started to look at transformation, and while we were looking at transformation, CTCT has gone private. And we've also acquired another company called Retention Science, and they deploy everything in the cloud. So really, 2020, towards the back half of the year, is when we really started deciding that we need to transform. We need to figure out what we need to transform into, and we want to be able to make it so that developers don't really need to worry about where they're deploying. It should be the same in the cloud. It should be the same on-prem, and we'll pick where it makes sense. So that's really where we started with the cloud native transformation. As we started, we started defining the core principles of the transformation. And what we really wanted to do is we wanted to help developers focus on delivering business value. We wanted to find innovative ways to help our developers with the complexities of operating at scale. And because the technologies were changing and we were acquiring companies that did things differently, we wanted to be able to apply microservice best practices at the network layer in a scalable and sustainable way, and we didn't want it tied to a particular language or stack. We also want to be able to facilitate tools so developers would be able to experiment in production in ways that were low risk. So deliver functionality to production quickly and be able to experiment with our customers. And what was really important, the last of our principles, was that we wanted to build something that was better than what we had today. Developers actually really liked what we had today, and if we didn't build something that was better, we were just going to end up with a third or even a fourth way of doing things. So if we step back a little bit and just look at how we do microservices, or how we did microservices at Constant Contact, it really kind of boils down to, we have clients that are outside of our firewall. They want to make requests to our APIs. And at the end, those APIs are fronted by gateways, and then we have a bunch of internal microservices that are not exposed directly to the internet, but are exposed to, gateways and other services. So the thing that ties everything together here is all of these internal microservices. We have firewalls between our clients out on the internet. The requests come in generally through a load balancer, and they hit a gateway. And when I say gateway, I mean it's an application. Generally on the on-prem side, they're home-rolled applications that basically authenticate and authorize requests. They do some of the other security things like, logging and auditing and CSRF protection and cores. They're handling rate limiting and request batching and caching. They're doing a bit of normalization and transformation of payloads as they traverse the public to private boundary. And ultimately what they do is they're responsible for translating requests from outside of our firewall into things that can be handled by our internal systems. When they invoke the microservices, all of our microservices before were running on a flat private network. So that means all of our services are running on one single network. When we want to integrate another, for example, another system that's maybe in a different cloud or in their own VPCs, either we have to stand up a new gateway, or we need to figure out how to get everyone networked in a way that makes sense, which is complex. So on the cloud side, we're doing things with Amazon's API gateway, but a lot of the same work is going on, right? We're using a little more of Amazon's API gateway. We're not rolling the whole thing from scratch. So, see rate limiting and things like that. But we're also having to add functionality there that's very similar to what we're doing on the on-prem gateways. So we're using things like Lambdas to do authentication and authorization and to do dispatch to our internal microservices. And, so what we're doing is we're doing a lot of duplicated effort. It's a little bit different depending on if you're going into AWS or the cloud. And we have our application gateway, which is used by our browsers and our mobile clients, and then we have other API gateways that we're using for third-party developers and our clickstream data. And things are getting they're a little bit fragmented, right? Like I explained. If we jump in just a little bit deeper, this gives us a good idea of what the actual traffic flow looks like, and how we're doing things behind our gateway. So the client comes in. It wasn't on the last diagram, but typically they come in and they hit a Cloudflare POP first. The request gets sent to an external load balancer that's running outside of our firewall, and we effectively firewall off everyone except for the Cloudflare POP. So you have to come through Cloudflare to get to our system. Once we get through there, we have some libraries that we've implemented because we have multiple gateways. We want to share this logic for handling some of the session stuff. So how our cookie gets thrown down on the browser, some CSRF protection, authentication and authorization. So just knowing the user's logged in is not enough. We have an RBAC-based system that we want to route requests against. And then when our gateways need to call an internal microservice, we've packaged in a bunch of functionality related to how we're discovering other services, how we're authenticating to other services, how we're pulling secrets from our secret store, and that internal service is behind another load balancer. It's discovered via a well-known DNS name. And once we get in there too, we have another set of libraries to authenticate the east-west type of API traffic and some more rate limiting things, because rate limiting at the edge is different than rate limiting internally. So now that we've kind of jumped in and we understand some of the issues we have, or we see how things are actually working, we have a couple of issues here that make things harder for us than we'd otherwise want them to. So our use of DNS-based service discovery, it makes it really hard or more risky than we'd like it to be able to swing a service to another data center. For example, if I wanted to move a service to AWS, I'd have to repoint DNS, and it's not the best way to route traffic. We'd like to do it some other way. It's hard to swing back. DNS is slightly unpredictable. It's not always implemented correctly. The other thing we have is, because a lot of these shared concerns like rate limiting and back off and retries, they're implemented as libraries, and even on the Java side, it looks different than what we do on the Ruby side, because Java apps, we have things like the Netflix OSS stack, we have retries and backoffs and circuit breakers, but it's not the same as what we're doing on the Ruby side. And because we don't have centralized places to manage these policies about how we do backoff and retry, and we don't have the same set of tools, it's really difficult to reason about what's going to happen if one service goes down. We've had problems with things like thundering herds and retries. And on the engineering side, the real downside here is we're stuck maintaining a bunch of libraries for things that might be better implemented in open source, or there might be better ways to do things now. And when we do have to update these libraries, if we have 200 microservices that are running the library, that's 200 deployments. So, if anyone had to deal with the fallout of Log4Shell, what the impacts are of a vulnerable library that you have to ship to a bunch of different clients. So we want to really start thinking about the way we're doing things, because right now we have a high cost of operating each microservice. And the last problem that we have here is that because we have all these libraries for different languages and ecosystems, if we want to adopt something new, if someone came to me today and said, "Hey, Dave, I want to write a Go app, or I want to write a Node.js app," the first thing we'd have to do is re-implement a lot of these things, like our custom homegrown authentication logic, it's not ideal, right? We want to be able to let teams pick the right tool for the job. So, we started off, and I'll hop over to the next slide. We kind of got a high-level idea of where we wanted to go. And this was kind of done iteratively as the application team was developing their application. We were iterating on the architecture, which was very helpful for us. So we kind of started with something that looked like this, but wasn't quite here. And we just started iterating, right? So what we ended up with, and this is kind of the idealistic state of the world, is, we found out pretty early, even before we had built this architecture, we thought that Istio, for a variety of reasons, would help us solve a lot of these issues. It would help us solve with, service failover and routing. And, I won't go into it in this discussion. You could have a whole talk on just the merits of one service mesh versus another, but we felt early on that Istio was the right solution for us. So what we did here is, one thing that's interesting is we still wanted to keep Cloudflare in the mix, so the browser goes directly to Cloudflare. But instead of going to a public load balancer that's firewalled, we're actually using something called Cloudflare D. Many of you may have heard of it. It's always previously called Argo Tunnels. But this was actually something that our security team had suggested to us. And for the first time in my career, the security team actually suggested something that was incredibly helpful instead of just another crazy requirement that we have to implement. But what it does is, so the traffic comes in directly to a Cloudflare POP. We have a service called Cloudflare D, or some pods running Cloudflare D in our Kubernetes cluster. And what they're doing is they're making outbound connections to a local Cloudflare POP. And traffic is flowing from one Cloudflare POP to another into our cluster without us having to expose anything directly to the wider internet, which is awesome. It also gives us the ability to kind of load balance across different clusters. So for example, we want to send browser traffic to a different cluster. We can do that up at the Cloudflare level. We don't have to do things like failover DNS. Cloudflare is terminating the original TLS connection. And at the end of the day, when we're through Cloudflare, we've come through Cloudflare D, we're hitting our Gloo Edge. And one of the things we really liked about Gloo Edge when we were looking at different options, we knew we wanted a Kubernetes native gateway. We looked at a bunch of options. One of the things that was great about Gloo Edge is that it integrates with Istio's SDS, and it becomes a first-class citizen in our mesh without me having to run multiple proxies up there on the edge. So that was a huge thing for us. In terms of the way traffic is flowing east and west, we have our services running across multiple clusters. We have our policies defined up in a separate cluster that we're just running Gloo Mesh in. So our traffic policies, our authentication and authorization policies, our retry behavior, those are defined up at the Gloo Mesh cluster, and they're relayed down to the other clusters via the agents. And one of the big things here is that when traffic traverses clusters, so all of our clusters for running applications have they actually have the same IP address range. And when they want to talk across clusters, they don't do so directly over a flat network. They do so via a load balancer that's ultimately pointing to an Istio gateway. For us, this is actually a huge thing because as we're integrating these companies into our portfolio, having a way that we can kind of talk to each other's services, product integration is incredibly complicated. The best we can do from my team's perspective is make sure that the getting things to just talk is not the complicated part. We can focus on the data integration and all the other problems that we have integrating these platforms together, right? So all a service in one cluster needs to do to talk to a service in other clusters be able to see its load balancer. And this is amazing, right? Because we've really taken a lot of the complexity out. One of the things we did right from the start that we wanted to do right from the start is we wanted to start with strict MTLS and make sure that we weren't having to back into it later. And like I said, the big thing here is that we don't require flat networking anymore. This is kind of where we wanted to go. But when we started, we knew we wanted to build a new product here, but the migration wasn't 100% clear to us. So we started going. Some of the problems we ran into is that not every place we wanted to run software, we could run a Kubernetes cluster, or some of our Kubernetes clusters might be old. We didn't have a solution. So when you start off with this new architecture, you don't have a lot running there. You're going to need to call other things that haven't been moved to the mesh yet. We didn't know how we were going to replace a lot of the functionality we had in our gateway. When you write your own gateways, you can do anything you want. And then when you move to something off the shelf, you're a little bit more constrained. So we weren't sure exactly how things were going to look. So let's start with how we implemented our gateway functionality. So one of the things that we did that I thought was relatively interesting is we wanted to use whatever gateway, in this case Gloo Edge, we wanted to use as much functionality as we possibly can at the gateway level. So, authentication, authorization where possible, common logging, how we operate, how we scale, how we monitor. That was really important to us. But at the end of the day, we had parts of the gateway that we had written. So particularly, the way we're doing request patching, the way we're doing the request transformation, that was likely going to have to live in code for some time. So we wanted to make sure that we could leverage a lot from Gloo Edge, but still keep the code around that we had today to do some of these more complicated things. And what we came up with is that we actually started using Gloo's custom XAuth server, which was actually changed the way we did things. So just for a quick example, imagine we have a client somewhere out there. It's a browser. It wants to create a campaign, a marketing campaign. It has a cookie that was laid down, by our session management system. Doesn't matter exactly how it works, or in this case, it was actually, let's imagine it was laid down by Gloo Edge because we're using Gloo Edge's OIDC to authenticate the user. But just knowing who the user is in our system isn't enough. Just because you can log in doesn't mean you can do whatever you want. So when the request comes in, we want to be able to figure out, what account you belong to, what your user ID is, what your permissions are, maybe have you paid, can you even use this product? And that's really hard to shove into the gateway. Maybe we couldn't even do it. So one of the first things we did is we implemented our own custom XAuth for Gloo, which what it allowed us to do is have Gloo do the first level of authentication check. So, is this user logged in? Do they have the right token? Is it valid? We put all that at Gloo Edge. After that check passes, we call a second XAuth server, which allows us to additionally can veto the request at that point. So we can decide we don't want to let it go through, even though the user's logged in. Maybe they're banned from our system. But what we can also do is once we say, okay, this user's allowed in, we can then instruct Gloo Edge to add a bunch of headers about who the user is, and then pass those along to our external API where we can start to do the transformation, the invocation of downstream systems. We can keep that logic there in our code while offloading a lot of what's the session cookie and how do I look up the user and all that stuff. That's up at the gateway. And then the external API gets those things as HTTP headers. And they can trust those headers because Glue Edge is part of our mesh. The external API is part of our mesh. And we use Istio's policies to say the only thing that can talk to that external API is Glue Edge. And then ultimately, that will have to invoke some sort of internal microservice. So how that looks, right? So as we started, right, we had most of our functionality is outside the service mesh. That's where we started. And we quickly had to figure out, well, if we're going to build anything in this new mesh, how are we going to call the old things we have? And what we decided was we were going to implement a sort of a strangler pattern. So what we did is we built a proxy that allowed us to talk back to our internal microservices. And it would abstract away how to talk to our legacy secret system. It would extract away constructing requests with the API keys that allowed us to call our backend systems. And it would hide legacy in this particular pod. And what was really cool about it was we were able to control access to this pod using Istio's native authentication authorization policies, which let us do things like, service A in the mesh could call our account service or our product service, but it couldn't call our billing service. And service B could call, the account service, but not anything else, right? Or it could only call gets on the account service. So we got this really rich permission model that we didn't even have for our old system for new services running in the mesh. And this was actually really something that allowed us to ultimately deliver a product on top of the service mesh. And now we have a variety of services running there, and they're able to integrate back seamlessly to our legacy system. So at the end of 2021, or in the back half of 2021, we did it. We shipped a product. We had it out in production. We're getting feedback from customers. It's been mostly positive. But a lot of the things we did, we had solved one direction in the mesh. We call in the mesh to out of the mesh, and that wasn't a major issue. But the other way was a problem, and because of it, we had implemented some things in some suboptimal ways. And it was mostly because, for example, if we had a reporting system running outside the mesh that was aggregating reporting stats from all these different things, it couldn't talk back into the mesh. Now we had to re-implement that functionality somewhere else, and we didn't want to do that. The other problem we had is that kind of as a consequence of the way our system worked before, every API or internal microservice was secured by an API key. Developers had gotten really used to being able to develop a microservice on their local machine and just invoking it, right? So I could build my microservice locally, I could play with it locally, it could call real things in our QA environment, and they had gotten used to it. But on our service mesh, we had ultimately made things too secure. It was difficult to invoke things running inside the service mesh. So we had these two problems, and we didn't really know how to solve them at the time. So I basically had started, we had looked at a couple of different approaches, and one of them that we thought might work is we started looking at Istio's VM integration. But for anyone who's looked, it ultimately couples your VMs to a particular Kubernetes cluster, which means that when you recreate a Kubernetes cluster or you want to upgrade it and flip over another one, now you have to move those VMs with it. So we didn't really like that. We weren't sure about how we were going to automate moving service account tokens, which is how Istio's VM integration works now. And we didn't think this would work for, we didn't think this would work for a developer laptop. So at some point, I went to Nick at Solo, and I said, I'd love to be able to run an Envoy proxy in a VM or in a, on my development machine. And basically, I think I can make it talk. If I can get the certificates it needs, my hope is that I can get it to talk to our Istio clusters via those east-west load balancers that we had popped out and we had talked about earlier. And what we ultimately came up with as a way to integrate these two worlds, for the short term anyway, and maybe for the long term in other ways, but we basically were able to operationalize what Nick's posted on the Istio blog, and he's calling it, or Solo's called it, VM one way, which allows essentially, instead of having the two-way communication that you get with Istio's VM integration, it allows something running outside of Istio to invoke services inside Istio. And basically how we built this is we took an off-the-shelf Istio proxy. We built a very small control plane for Envoy based on Go control plane, and we even implemented some XDoth. So what this lets us do is this effectively lets us make service calls from outside of our Istio cluster. For example, if we have an old Kubernetes cluster that it can't run the same version of Istio for a variety of reasons, and we're not going to upgrade it for 6 months, it's fine. We can use this. We've implemented XDoth, like I said, so that way, for example, you have a service running in the mesh. You want to expose it outside the mesh, but we want to do it in the way that Constant Contact does its old services, the way it does API keys. We can do that too. Oh, and by the way, we can even run this on a developer laptop. So that's currently something that we're working on doing today. It just requires essentially you to operationalize the delivery of certificates. So with that said, real quickly, 2022 is the year that we're adopting Istio at Constant Contact. We're going all in. So it's been a resounding success. It's been ultimately a fun journey. We still have a lot left to go. And with that, I just want to say thank you. Thank you for listening to me. I'll be here to field any questions you have. And yeah, I'll just say goodbye. Thank you very much.